Hello students, another doubt solving sessions from your Neet book. See, what is the first question given to you? Which of the following has highest chlorine content? Basically, this is a very simple thing. I couldn't understand why did you ask me this? This is very simple. Chloral, if you know the formula, chloral is CCl3CHO. DDT is CCl3 like this, CH and a phenyl ring with a Cl and a phenyl ring with a chlorine. Okay, pyrene is CCl4 and gamexane is like this, every carbon having one H1Cl, one H1Cl, one H1Cl, and here also one H1Cl, one H1Cl. These are the structures. No, it's so simple. You have to just compare who has highest chlorine content. So my dear, you have to just see total molar mass and in that how much chlorine is there. So total mass of chlorine upon molar mass of the molecule into 100. You get the percentage. Suppose you take this one. What is the total of this? Find out. I'll just give you an idea. I'll not solve, just give you an idea. Say carbon mass is 12 plus chlorine 35.5, 3 times. Another carbon 12, hydrogen 1, oxygen 16. If you just add this. Whatever total is there, that is molar mass. So total mass of chlorine upon molar mass of the molecule into 100. When you do that, solve everyone. When you do that, you will get the answer as this. This has highest chlorine content. Because this will be 4 into 35.5 upon 12 plus 4 into 35.5 into 100. This will be maximum. You can just see and understand. Even no need to calculate. It's a CET exam. Everything you need not calculate. In the presence of AlCl3, benzene and N-propyl chloride react to give. Now see, the moment I see AlCl3, this reminds me of Friedel-Crafts reaction. Friedel-Crafts reaction. Now how the reaction gets initiated? When I take N-propyl, okay, alright, a little bit that side. When I take N-propyl chloride, it combines with AlCl3 to give me AlCl4 minus plus CH3, CH2, CH2 plus. Now this is a 1 degree carbocation. You know 1 degree carbocation is less stable than 2 degrees. So this immediately interchanges into a 2 degree carbocation, which is isopropyl carbocation. This is formed. Now rest is very simple. This isopropyl carbocation attacks benzene and benzene undergoes electrophilic substitution. You know one bond will break from here. This carbon will acquire negative, this will acquire positive charge and you will be getting isopropyl benzene. Isopropyl benzene. Only thing you have to keep here in your mind is that when N-propyl chloride you take and it dissociates to give N-propyl carbocation, then many of you will do the mistake, and that mistake is you will just attach N-propyl to benzene, which will be wrong. Because N-propyl carbocation will get interchanged to isopropyl carbocation. Since we know 3 degree carbocation are more stable than 2 degree and 2 degree is more stable than 1 degree. So obviously primary N-propyl carbocation will get converted to more stable sec-propyl carbocation, and when that sec-propyl attacks benzene, benzene undergoes electrophilic substitution to give isopropyl benzene, also called sec-propyl benzene, also called cumene, also called 2-phenyl propane. Okay, now here RCl is treated with Li in ether solution to form RLi. RLi reacts with water to form isopentane. Okay, that's fine. This is only clear. See, RLi. So what is R? R will be isopentyl. Anyway, we further confirm. Once again, I am repeating. Alkyl lithium reacts with water to give isopentane. मतलब lithium निकला और उधर H आया. Isopentane will come from isopentyl, meaning this is isopentyl lithium. Anyway, further we see this RCl reacts with Na to form 2,7-dimethyl octane. It's very simple. If I write 2,7-dimethyl octane, this is octane. 2,7-dimethyl. 2 पे एक छतरी है और 7 पे एक छतरी है. This is 2,7-dimethyl octane, just adding the required number of hydrogens with Na. अब Na है यानी कि Würtz reaction, and Würtz reaction में you get alkane having double the carbon atoms than alkyl halide. Once again I am repeating, in Würtz reaction you get alkane having double the carbon atoms than the alkyl halide. So if double the carbon atoms are 1, 2, 3, 4, 5, 6, 7, 8, then before doubling, double होने के पहले ये इसका आधा होगा, बिल्कुल आधे में काट दिया इसको, कट, तो क्या बच गया? CH3CH, इधर ऊपर एक छतरी और इधर CH2 और इधर ये शेंडी क्रिएट जो हुआ, यहाँ है Cl. So this is the structure of RCl, which is 3-methyl, which is 1-chloro, 3-methyl butane. Yeah, so I hope this is clear to you. Okay, now ethyl benzene reacts with bromine in presence of FeBr3. This is also interesting. Bromine with FeBr3 is again electrophilic substitution of benzene. देखो क्या याद रखना है, जैसे हमने क्लोरीन AlCl3 में लिया, क्लोरीन डार्क में लिया, ब्रोमीन डार्क में लिया, ब्रोमीन FeBr3 में लिया, तो इलेक्ट्रोफिलिक सब्स्टिट्यूशन. और अगर कहीं मैंने क्लोरीन इन सनलाइट लिया, क्लोरीन इन डार्क नहीं लिया, क्लोरीन इन सनलाइट लिया, if I take chlorine in sunlight, then it will be free radical substitution. और ऐसी सिचुएशन में बेंजीन पे अटैक नहीं होता, साइड कार्बन पे अटैक होता है. But this is with bromine and FeBr3. तो ये तो बेंजीन पे अटैक होगा, and benzene always undergoes electrophilic substitution reaction. In this case, so Br2 reacts with FeBr3 and gives us FeBr4 minus and an electrophile Br plus. Br plus is called bromonium, which is a electrophile. This is a electrophile. Now this electrophile will attack ethyl benzene. This is ethyl benzene. This electrophile will attack ethyl benzene, and you know very well ethyl is a electron releasing group with a positive inductive effect, and positive inductors are ortho para director, और ortho para में para is more stable, तो यहाँ para product major मिलेगा और ortho minor मिलेगा, यानी ऐसे para bromoethyl benzene, this will be the major product. Okay, now we come to the next question, and that's ethyl chloride with Ag2O. Okay, very simple. When I take ethyl chloride and I treat it with Ag2O, and this is dry condition heat है, तो ये दो molecule use होगा, CH3CH2Cl and ये गया AgCl. So you'll be getting diethyl ether plus 2 AgCl. Okay. Now the next reaction, ये तो बहुत simple है. Ethyl chloride with chlorine will give chloral. CCl3CHO, chloral. This you should be knowing, yaar. We are asking same thing so many times. This is there in our notes on page 84. Page 84, our notes. Page 84, our notes. It is, if you take ethyl alcohol and treat it with chlorine, then first you get ethanol, and reaction doesn't stop there. Again it reacts with chlorine and you get chloral. Okay? Which of the following compound gives both iodoform and Fehling? See, iodoform test is given by whom? Ethanol. Only one primary alcohol gives iodoform test, ethanol. Only one aldehyde gives iodoform test, ethanol. Only secondary alcohols having OH on second carbon give iodoform test, and only ketones having own group at second carbon give this test. While Fehling test is given by aliphatic aldehydes and not aromatic. Aliphatic aldehydes. Okay. So let us check. Propanone will give iodoform test but will not give Fehling. Ethanol will give iodoform but will not give Fehling. Methanol will not give iodoform only. Forget Fehlings. It will give Fehlings but no use. Ethanol will give iodoform and it is aliphatic aldehyde. It will give Fehling's test also. So when ethanol combines with NaOI, we get iodal. This iodal immediately decomposes with NaOH to give iodoform. And when ethanol, that is acetaldehyde, reacts with Fehling solution, which is solution of copper sulfate and sodium potassium tartarate. Fehling solution is a solution of copper sulfate and sodium potassium tartarate, where we can say it is a solution of copper sulfate and Rochelle salt. Sodium potassium tartarate is also called Rochelle salt. So here what happens? This Cu plus gets reduced, this plus 2 gets reduced to Cu2O, which is plus 1. So reduction of this solution takes place. This solution is blue in color and this precipitate of cuprous oxide is red in color. It is cuprous oxide. So the blue Fehling gets converted to red cuprous oxide. This process which is taking place from here to here is reduction. While the carboxylic acid, while the aldehyde gets oxidized to carboxylic acid, and this process is nothing but oxidation. This is a type of redox reaction. So you get Cu2O plus acid plus you get water. So that's how Fehling solution is reduced by aldehyde. So aldehydes reduce Fehling solution. They convert blue Fehling to red PPT of cuprous oxide, but this is done only by aliphatic aldehydes and not aromatic aldehydes, because aromatic aldehydes are less reactive and Fehling solution is also a weak oxidizing agent. Fehling solution oxidizes aldehyde to carboxylic acid, while aldehyde reduces Fehling to red PPT of cuprous oxide. So this is a redox reaction where aliphatic aldehydes get oxidized while Fehling solution get reduced. So this is a type of redox reaction. Okay children, so that's all. One more doubt session on this and then we'll be completing all doubts of our JEE and Neet book. And then we immediately begin with the next topic. Bye-bye. Take care, love and blessings.